Okay, so now what we're going to do is basically before we write the interpretation, we've done steps 1 and 2. We did all the by hand work for step 3. We're going to put the data into JAMOVI and we're going to check all our work. The way that we're going to do the class is that we want you to do both of these steps every single time. The way that you'll really understand the way that the computer is making decisions, or at least in this, and again, if you want to do this in SPSS or R, that's totally fine. Again, I think I've said this before, one of the things I like about JAMOVI is you can come over to this little ellipsis, you can turn on syntax mode, you can then download the JAMOVI package into CRAN, you can write in R, you can compare it to the psych package and other types of things like that. You get lots of similar types of answers, but I'll show you some of the things I really like about JAMOVI. Okay, so this data set, really small, pretty straightforward. All I've done so far is I've entered in this post-intervention gratitude variable, right? And I have all my 12 participants going down in the first column. One of the things that we'll talk about once we get into independent samples t-tests, this will be important next week, is that each column carries variable information. So this is the variable for the participants, not used in any analysis, but if I have to merge the data or if I have to check my work, I need to know like if I accidentally entered in the wrong data, and certainly when we do this by hand, that happens, where that data set may have gone wrong. Gratitude in this case is considered a Likert scale variable, and so therefore it is continuous. I can compute the mean and the standard deviation for that. So as a matter of fact, let's go ahead and compute the mean and the standard deviation for the gratitude variable just to get a feel for it. So if I go to the descriptive statistics here, you'll notice that in JAMOVI this will go a little bit slower because I'm running Zoom in the background. I can take my gratitude variable, I can move it into the descriptive statistics, and I can see some of the values that I have computed in the past. This is a really good first step to do before you actually put all the data into the one sample t-test. I'm not interested in the median, but I am interested in the standard deviation, and I am interested in the standard error of the mean. And so here, we see some slight differences. Again, you remember earlier in our by hand work, we got a standard error of the mean of 2.94. The reason for that was because of some of the rounding rules. We ended up with a 2.93, I think it was 6, was in the third decimal place. And so we rounded up. Again, those are tiny differences that are not consequential in the way that we go and interpret our data. But here you'll see why we might get slightly different results, and ultimately why we're going to write our conclusion based on the output that we get from JAMOVI. So the test that we're going to learn this week is the one sample t-test. The one sample t-test is a pretty easy test to run because there's not a lot of things to do in it. Again, if you want to do this in a different package, that's fine. But there's a couple of things that I'm going to really advocate that you do here that are really important. So first, you'll notice that the test over here in the test section gives you some different options. So this is students t-test. This is assuming the t-distribution. It is the default for this procedure. One of the things that you'll notice is we do have one assumption check. We haven't talked a lot about this because a lot of the assumption checks are much easier to do in JAMOVI or SPSS or R or whatever in our statistical packages than they are to do by hand. So when we do things by hand, we just assume that those assumptions have all been met and we don't do much else with them. But I want you to turn this off because you shouldn't actually select the student's t-test until you've actually been assured that you meet your assumption. The only assumption that we can really check here, because we don't have any variance assumptions that we can look at, we don't have a homogeneous variance estimate that we can compute, is the normality of this. So when I take the gratitude variable, which is my outcome of interest, and I put it in here, I want to do two things. There's two places where people will make mistakes in this test. The first is you'll notice that this test value defaults to 0. It should unfortunately default to whatever your null hypothesis value is, which our null hypothesis was that the population mean should have been 14. It didn't ask us what that was, so it defaults to 0. Now, it would be better if it just didn't default to anything and it just made you enter this number in and basically said, what is your null hypothesis? So one mistake that people often make, again, when you're going a little too quickly through Jamovi, and it begs you to go quickly because it's just point and click, is that they don't put in the right test value. We will check that, right? We will give you an answer option that's equal to, if you keep the test value at 0, which will be wrong because my null hypothesis is not that mu1 is 0. My null hypothesis is that mu1 is 14 because that's what the population parameter is for mu0. If you don't do that change here, you'll have an error in the way that you interpret the data. If you turn the normality option on, we'll actually get some normality statistics over here. These normality statistics, I don't want to spend a lot of time talking about them, but I want to make one point really quick, which is that we want all of these p-values. This is the only time I think we want to, which is the common rule is that we want our assumptions to have p-values that are greater than 0.5, and we want our null hypothesis to be less than 0.5. Again, that's not the only time that would be true, but that's a general rule. These say that I don't deviate significantly from normality. How do I know that? Each of these p-values are greater than 0.5. What that ultimately means is that since I meet the one assumption that I have for the single sample t-test, then I can use it. If I could not use this, and if these p-values were less than 0.5, then I would use the Wilcoxon ranks nonparametric equivalent. One of the things I like about Jamovi is that it gives you a little section over here that has you check your assumptions. You can do the QQ plot. It's a visual representation of normality. If you look at this here, I have no idea how to look at that and tell you if this data is normally distributed or not, or if the assumption for normality is met. Maybe some people are better at visual inspection than I am, so I don't use the QQ plot. Again, so as long as these p-values are greater than 0.5, then I can use the student's t-test, right? So, again, Jamovi's point and click, it's going to be pretty fast when you get all the information out. So don't rush through this process because ultimately it's going to be one of those types of things where if you don't do the simple things really slowly, if you don't change your test value, if you don't check your assumptions, you may ultimately end up running the wrong test or having the wrong numerator and therefore end up with the wrong conclusion. That's basically all we have to do before we do the stuff that we're really interested in. So first we'll click on students t-test. We'll see up here, I like this, it actually says that the alternative hypothesis is that the population mean post-intervention is not 14. That's it might also be better if it had the note that the null is that it is 14. Here is the t-statistic that we got by hand. Notice that it's called the student's t-statistic, which is 1.02. And again, one of my old mentors said that the best way to understand output is to first do everything by hand and then look at the output and see where you're getting the exact same numbers, right? So our test statistic here is 1.02, which means that our t observed here, this is what the t observed ultimately is. It's 1.02. You'll also notice that it tells you that this student t-test is done with 11 degrees of freedom. We did this in step number 2 when we actually were getting the critical value. Notice it doesn't actually give you a critical value. I've never seen any critical values reported, unfortunately, in any statistical software packages. It's not an SPSS, it's not an R, at least not in the R packages I've used before, but you can see that the degrees of freedom here are 11, so you can go look that up in the t-test table, which would give you a critical value of 2.201. So if you don't know that critical value, if you skipped step 2, which you shouldn't, then you can go look it up at this point. And we can see that this value, again, it would be really nice if someday they actually make little graphics that have sampling distributions with the center of the distribution and where your actual value fell. It seems like it'd be great for those of you that have some coding and graphic design aspirations. I would love that. I've never seen that before. I think it would totally sell. When you make your $1 million, just send me a check. Okay. And all we had when we did this by hand was that the p-value was greater than 0.5, right? So at the very end Actually, no, I guess it's the middle of step 3. We know that the p-value is greater than 0.05. We didn't know what the exact p-value was, but APA style says to 3 decimal places you should report the exact p-value. So our p-value is 0.328, which is clearly larger than 0.05. If this value was less than 0.05, if it was 0.12 or 0.012 or 0.003 or something like that, we would report that value. So in your APA style conclusions, the way that we're going to structure this is you're going to do step 1, step 2, step 3, all by hand. Then you're going to enter the data into JAMOVI, and then you're going to write the interpretation based on the output that you have in JAMOVI. So that JAMOVI is what you base your interpretation on, but your by hand work helps you understand the output they're actually looking at. There are some other statistics that we are interested in. Remember, there are 2 confidence intervals, so we can get the mean difference. You remember the 95% confidence interval around the mean difference was negative 3.47 to positive 9.47. Because we're going to get a slightly different standard error when we don't use the same exact rounding rules, we're going to get a slightly different confidence interval. So here we had negative 3.47. JAMOVI with slightly different rounding rules gets negative 3.46. Again, inconsequential in the ultimate conclusion of what that tells us. It's just off 1/100th. That's only because of slightly different rounding. And I'm just gonna live with those differences there. But you'll also notice when you look through this, one of the things you don't get is you don't get um, the JAMOVI, at least to this point, as of this recording on this morning, still does not provide you the 95% confidence interval around the mean. It does give you this is the mean difference and the 95% confidence interval around the mean difference, which is important in our APA style, but is not something that we would only report. We would also report the 95% confidence interval around the mean. Interestingly, if you click on the descriptive plot, it's an okay plot, it'll pop up here. It's a little bit slow. This is actually the 95% confidence interval around the mean. So this is 17 plus or minus my interval of what they are having as 6.46. Right? Which also is my median here. So this is not too surprising that the mean and the median are pretty close because the data was assumed to be normally distributed, right? So you can see that there's actually a 95% confidence interval around that mean. It just doesn't provide it in the output up here. The way that you can get that is if you click on the descriptive statistics, you get the standard error here, you get the mean here, you know what the degrees of freedom are, and this gets into one of the rules. If you've had my classes before, you'll remember I've said this, that all statistical software packages give you everything that you need, but not everything that you want, and that's just the reality, unfortunately. So I want the 95% confidence interval around the mean because I'm going to report that in APA style. Unfortunately, all I have is the mean, the degrees of freedom, so I can go look up the critical value and the standard error, right? So you can then just put that into a calculator. Even if you do everything in JAMOVI, you are required to report that. We will report this using the same rounding rules that they used, so ultimately we'll have slightly different confidence intervals around the mean because of the way that JAMOVI computed the standard error. The last thing that we can get is a D effect size. You'll notice that it was reporting Cohen's D here. The D effect size is the same as what we got by hand, a D effect size of 0.3, which is a small difference. So again, we talked a little bit about this on the lecture, and I want to really point this out. One of the reasons we actually get a D effect size is that in this case, even though it wasn't a large difference, it wasn't a trivial difference. So remember in lecture number 4, we had a significant difference in the percentage of positive emotion words that people had after having their news feeds changed. But the D effect size was 0.012, trivial, tiny, just a small smidge of things. In this case, we retained the null, but our D effect size estimate is that it is small. Some people might ask, well, how could that occur, right? So how do we get those situations where sometimes the p-value tells us that it's significant, but the result is trivial? Well, in that case, we had a ton of people, 155,000, and we had a small difference, and so we were able to detect that. So with a ton of people, we have tiny, tiny, tiny standard errors, and therefore we're able to detect trivial differences. Whether we care about the trivial differences, that's a different question. In this case, we only had 12 people. You might think that's kind of a small intervention. It actually really is. This effect size estimate might say, hey, if you collected more people, your standard error would shrink up, and maybe ultimately you would get a confidence interval that is not containing zero. And one of the two things that has to happen is, as I collect more data, if this p-value, so as my sample size increases, if this p-value stays above 0.5, this confidence interval is going to go closer and closer to zero. As a matter of fact, even though we don't report it in this class because it's really a pain to do by hand, you can actually see that there's a confidence interval around, this is the confidence interval around the D effect size, right? And of course, just like you would expect, the D effect size could be negative, zero, or positive because the directionality, the qualitativeness of the data is the same way. So I'm 95% certain that if I collected all the data in the population, had everyone go through the intervention, that these two negative numbers say that people in the post-intervention group would actually be less grateful. That's why they're negative, because of the way that I structured the numerator. A zero means that there's still no difference, right? A D effect size means there's no difference. And a positive value shows that they are actually potentially more grateful and quite a bit more grateful in this case. So we don't report this D effect size confidence interval in the APA style. Some journals may ask you to do that. This is where it's located. The reason I don't ask you to report it is because it's just a pain to do by hand. And so what I want you to see, though, is you can get it, and you get relatively the same qualitative information you get out of the 95% confidence interval around the mean difference. But again, one of the things that you'll note is that if I collected more data, one of two things would have to happen. Either this p-value would become statistically significant, or this D effect size, this confidence interval would shrink up and maybe get closer and closer until it's only capturing nearly zero. So maybe it's trivial on both sides, negative 0.02, positive 0.02. So zero is in the middle, but it's, even if I get 155,000 people, I'm gonna have a result that's so small it's inconsequential and not interesting. Okay, so now you're going to answer the questions based on the data set with JAMOVI, and then we're going to come back, and in the last video we're going to walk through how to write up all of this JAMOVI output in APA style.